Lesson 1-5, Add and subtract rational numbers. The only difference between this lesson and our previous lessons is that now our numbers are going to include fractions and decimals, whereas before we were only worried about integers. Take a look at your solve and discuss it. See if you can find an easy answer to determine where points A and B could be located so that the difference between them is 120.5 meters. I took the easy route. Since A is below sea level, I made A negative 20.5 meters. And since B is above sea level, I made B a positive 100 meters. Now you might be thinking, well, how do those add up to be 120.5? Remember that this would be a subtraction problem, and the difference between those two distances is 120.5 meters. The essential question in this lesson asks us how are adding and subtracting integers related to adding and subtracting other rational numbers. So one thing that we will do as we are working through this lesson is look to see if our rules for adding and subtracting integers also apply here. Example 1. Lava floats from an active volcano's magma reservoir located below sea level through the magma conduit. How far is the summit of the volcano from sea level? Okay, besides the fact that there were a whole bunch of extra vocabulary words in there that relate to volcanoes, what we're really looking for here is how far apart are the summit of the volcano and where that lava is activated below sea level. Now you'll notice in the picture here that they have identified, oops, sorry about that, let's try that again, that they have identified the distance between the two as 5 1/4 miles. However, the distance below sea level is the 2 3/4 miles. So what we're looking for here is how can we figure out the distance between the summit and sea level? So that's this distance here. There we go. Okay, so one of the things that they teach us to do is to look at this from a number line standpoint. And you can see here on the number line that you've identified, or they've identified a distance, total distance, of 5 1/4 miles. And they've also identified this point right here on the number line at negative 2 3/4 miles, because that's how far below sea level that magma reservoir is located. From negative 2 3/4 on the number line, a distance of 5 1/4, so going up here to 5 1/4, what we're looking for is what is this distance here between the summit and sea level. So how far do I have to go on my number line to get from 0 to where that 5 1/4 miles would end up being after I travel that distance to the summit from that reservoir? So what we actually have here is an addition problem. You can see that right here. And we can use our rules for adding integers and apply them also to rational numbers. So even though there are fractions here, don't freak out. Remember, you just have to get a common denominator when you find when you have to add or subtract fractions or mixed numbers. So you'll see that they've done that. We've made sure that you have common denominators already. You just have to do the fraction computation. So a negative 2 3/4 plus 5 1/4 is a difference of 2 1/2. Remember that this is going to be a positive difference here. Okay, and it's positive because you have more positive value than you have negative value. So we know that the summit of the volcano is 2.5 miles above sea level. Now I'd like for you to complete the try it. See if you can fill in the boxes and use the number line to answer this question, and come back when you're done to check your answer. To help you get started, I've made a point of showing you where negative 4 1/2 feet would be on the number line. Remember, that's the dolphin's location relative to the surface of the water, and the surface of the water would be up here at 0. Okay, and then it tells us that the dolphin swims down another 2 and 3/4 feet. So this is actually going to be a negative 2 3/4 feet. And we're going from that negative 4.5 down another 2 3/4 feet, and to see where we end up at this point right here. So what we're looking for is to see, where do we actually end up? Okay, pause the video, see if you can finish, and then come back and check your answer. All right, check your work and check your answer. Hopefully you got negative 7 1/4 feet when you put together a negative 4.5 plus a negative 2 3/4. Now the Convince Me just asks us about how addition and subtraction of rational numbers is related to adding and subtracting integers. Well, to be honest, the rules are the same. So that is one thing that we don't have to worry about changing. So if you can remember how to do it with integers, you definitely know how to do it with rational numbers. You just have to worry about the fractions or the decimals. Take a look at example 2. In this example, you're looking at thrust and gravity as it pertains to a model rocket. The thrust is given to you as a rational number in a mixed number format, 1 1/2 newtons. And the gravity is given to you as a decimal, negative 49/100 newtons. So as you're working to solve this problem and add those two rational numbers together, you're going to have to make sure that you put either the fraction and mixed number into a decimal form or change the decimal into a fraction. The book has selected to change 1 1/2 to 1 5/10 in order to make both of them decimals before subtraction is possible. So the combined force on the rocket is 1 100 newtons. Now I want you to take a look at the three triads. Although they might seem intimidating, I'd like for you to try them and then come back and check your answers. As a helpful hint, for most of these questions, it may be easier to change the fraction into a decimal and then work with the decimal numbers. Take a look at your three answers from the Try It questions and see if they match. If you have questions about what I've done, please ask. In this example 3, we're looking at finding distances on a number line. Remember, a number line can help you see or visualize distances between positive and negative values, which sometimes makes more sense when you're stuck about whether or not your answer should be a positive number or a negative number. So in example 3, it says, Ruby looks over the edge of her boat and sees fish 4/10 of a meter below the surface of the water. If Ruby holds a 1 meter long net at 1/2 meter or 5/10 meter above sea level, can she reach the fish? Explain. Well, they do show us two ways of doing things. One way is to show Ruby's net at a 1/2 meter or 5/10 of a meter above sea level. So that's this on the number line. And right here, it's our first rational number and our absolute value signs. And then to show the depth of the fish, which is at negative 4/10 of a meter, which is 4/10 below sea level. If I find the distance between those numbers, I'm actually subtracting, and then I need to find the absolute value of their difference. So I'm finding the absolute value, which is the distance of their difference. So in the first way, I end up adding 5/10 and 4/10 to get 9/10. And that tells us that Ruby's net and the fish are 9/10 of a meter apart, so a 1 meter long net would be sufficient. The other way is to look at it from the fish's perspective. So if I start with the fish's depth at negative 4/10 and I take away from that the 5/10 of a meter, which is where her net is located, you're actually adding two negative numbers together. Remember, you have your add the opposite here, okay? And once you add the opposite, you get a negative 9/10. But recall that this is still a distance between those 2 points, and distances are always given to us in positive value. We always measure distance as a positive value. So those absolute value bars, which remember are those straight up and down lines, you see them right here and right here. The straight up and down lines tell us about a distance. So the distance is 9/10 of a meter. The direction tells us whether we were moving up or whether we were moving down on that number line. Now I want you to take a look at the try it. You can use a number line to help you, or you can use your scratch paper. See if you can solve the try it and come back in just a minute to check your answer. Take a look at your try it. Two divers are swimming at different depths below sea level. One diver, I'm going to call that diver A, is at negative 25 and 5/10 feet. The other diver, which I'm going to call B, is at negative 40 and 75/100 feet. How much farther below sea level is the diver who is farthest below sea level? So I guess the first thing you need to decide is which diver is lower in the water, diver A or diver B. If you said diver B is lower in the water, you're correct. So what we're looking for here is how much farther below sea level is diver B than diver A. Try this question on your own. Use a number line if you need to, and come back and check your answer when you're finished. All right, so I made a number line for you so you could visualize what was happening, and what we're looking for here is the distance between diver A and diver B. Hopefully you guessed that what you have to do here is subtract these two rational numbers. All right, so the next thing we want to do is to change this from a subtraction problem into adding the opposite. And when I do the opposite of this point A, the opposite of that is a positive 25 and 5/10. So now when you put those two numbers, rational numbers, together using your rules for adding integers, you would get a negative 15 and 25/100. So the diver that is farther below sea level is negative 15 and 25/100 feet lower in the water. Make sure you're taking these notes and writing down these steps in your book pages because this will help you later. When you're ready, just let this play through and we'll go on to the next set of problems. Okay, on the do you know how and the do you understand questions, what I'm going to do is give you some responses that you can use to help you practice these skills before you get to your Math XL assignment. So what I'm going to do is I'm going to ask you to try, or you can try on your own, questions 4, 5, and 6. Pause the video and then come back and you can check your answers for those questions. Okay, take a look at those three problems and their answers. You may need to pause the video so that you can check your answers before it goes on to the next page. Now I'd like for you to take a look at questions 7 through 13 on the practice and problem solving page. Let's work through these problems together so that you have a better understanding of finding the sums and differences of rational numbers. Take a look first at number 7. 3 and 2/10 take away a negative 5 and 7/10 means that we have subtracting a negative. So we're going to do that keep, change, change. So we're going to keep the first number, that's the 3 and 2/10. We're going to change the subtraction into addition. And we're going to change the second number into its opposite. And the opposite of a negative 5 and 7/10 is a positive 5 and 7/10. Now we have two positive numbers that we can add together. Okay, this is where the calculator would come in handy, and you can add 3 and 2/10 plus 5 and 7/10, or you can do it here on the side of your paper. And when you add them together, you get 8 9/10. Now, decimals are easy to do on a calculator, but fractions are not, okay? The only thing a calculator will help us do when we have fractions and we're trying to add them is to get an equivalent fraction or make equal fractions so that we can add or subtract them depending upon the denominators. If you take a look at number 8 here, you'll notice that our two fractions already have a common denominator, 13. So now we just have to add or subtract the numerators. So 12/13 is going to stay. And then we're going to do the same thing with adding the opposite. So adding a -1/13 is the same as subtracting 1/13. And here, remember what we're doing is the 12 minus 1. The denominator stays a 13. So 12 minus 1 is 11. And 11/13 our denominator stays the same. Now you cannot enter that into a calculator because if you do, the 13 as a denominator will give you a repeating decimal. Okay, so do not try to use a calculator to add and subtract fractions. Now take a look at number 9. When Tom simplified the expression -2 6/10 plus -5 4/10, he got 2 8/10. What mistake did Tom likely make? So here I see that Tom is adding two decimal numbers together and both of them are negative. So remember, when you add a negative plus another negative, you get a negative answer. So the first thing that I notice is that Tom's answer is a positive number, and negative plus negative will always equal a negative number. So when I put these two together, I am adding the 2 6/10 and the 5 4/10, and I get 8 0/10. It's going to be a negative 8 0/10 because negative plus negative equals negative. So what mistake do you think that Tom likely made? Instead of adding those two numbers together, Tom probably subtracted them. And it looks like he probably subtracted the 2 6/10 from the 5 4/10. So the mistake that Tom likely made was he likely subtracted 5 4/10 minus 2 6/10. But the correct answer should have been -8. All right, now I'd like for you to try number 10 and pause the video while you do that and see if you can find the temperature change from day to night. Come back and play the video when you're ready to see if you did the problem correctly. Don't forget to write the problem out first before you try to solve it. If you need a bit of a hint, remember that that temperature change is going to be the difference between the daytime temperature and the nighttime temperature. So a difference is subtraction. I want to know how far apart was the daytime temperature from the nighttime temperature. And don't forget, when you see subtraction, you can always change that to adding the opposite, or keep, change, change. So what was that temperature change from day to night? That temperature change is 49 2/10 degrees Fahrenheit. Now let's take a look at question 11. It has 3 parts to it, and if you'll notice, the first number is either 50 1/2 or -50 1/2 in all 3 questions. The second number is either 12 3/10 or -12 3/10, again, in all 3 questions. So we have a mixture here between fractions and decimals. Halves are easy fractions to change into decimal form. So when that is the case, it might be easier to change that into its decimal form and then work with adding or subtracting the decimals. Those are easy to do on the calculator. However, just be aware that if the fractions are not decimal friendly, okay, for example, if they repeat, then you cannot turn them into decimals, and you would instead have to turn your decimal numbers into a fraction. So let's change that 50 and 1/2 into its decimal form. So remember, when you change that to a decimal, the 50 is the whole number part. That's what goes in front of the decimal point. Then you're going to change 1/2 into its decimal by division, 1 divided by 2. And that gives you that 0.5 that you see on your calculator, which means 50 and 1/2 is the same as 50 and 5/10. So in each of these, I can change that 50 and 1/2 into 50 and 5/10, and then add those numbers together. So I want you to write those all out first. All right, and now go ahead and answer parts A, B, and C. Come back and check your answers when you're finished. Okay, go ahead and check your answers to parts A, B, and C. Notice in part A, your answer is positive, but in part C, same question, but the opposite number is negative, your answer ends up being negative. And for part B in the middle, that's the only one where you actually added the two numbers together because both of them were negative. All right, we have 2 questions left. Let's go with number 12. Number 12 says, at the beginning of the day, the stock market goes up 30.5 points. At the end of the day, the stock market goes down 120.25 points. What is the total change in stock market from the beginning of the day to the end of the day? So this is a scenario where we're going to subtract. Okay, we want the change. How much did it change from the beginning to the end of the day? So we're going to subtract that 30.5 and the 120.25. So I looked at the fractions and I noticed that halves and fourths are easily changed into decimals. We've already changed a half into a decimal in the last question, so I can use that same knowledge here to change 30.5 into 30.5. Now I have to change the 120.25 also into a decimal. So when I use my calculator to do 1 divided by 4, or think about how much money is 1/4 of a dollar, or a quarter, you get 25 cents. And then you're going to subtract those two values. Now, will your answer be positive or negative? In this case, you should get a negative answer because the number that you're taking away is larger than the number that you start with. In other words, the stock market went down more than it went up during the day. So when you subtract those two values, you should get a negative number. And again, use your calculator to help you with that computation. The total change in the stock market from the beginning of the day to the end of the day is a negative 89.75. Now let's take a look at number 13. This is our last question. A dolphin is swimming 18 feet below the surface of the ocean. There is a Coast Guard helicopter 75.5 feet above the surface of the water that is directly above the dolphin. What is the distance between the dolphin and the helicopter? So again, I am subtracting to find the difference between those two locations. So the helicopter is at 75.5 feet above, which means it's a positive number. The dolphin is swimming 18 feet below the surface of the water, so we know that that's a negative number. And we're going to subtract the two to find the difference between them. So what is 75 and 5/10 minus a negative 18? Is it positive or negative? Well, in this case, it's positive because distance is always going to be described as a positive value. So the difference in that distance between where the dolphin is and where the helicopter is a distance of 93 and 5/10 feet. Now you should be ready to go on to your work for lesson 1-5.